Okay guys, today we will learn about alcohols, and I have separated this video into two parts. Okay, we have reactions of alcohol is divided into combustion, nucleophilic substitution, reaction with sodium. All these three reactions we will cover in part 1, whereas esterification, dehydration and oxidation we will cover in part 2 of the video. Let's start with the first reaction. The first reaction is going to be combustion. Now, for combustion, we will have complete combustion for alcohol. And then this reaction, if you have a complete combustion, they are going to actually give you carbon dioxide and water. So this reaction must be done under the presence of oxygen, and it will give you carbon dioxide and water. Take note that there is no incomplete combustion for alcohol like what you have for hydrocarbons. So you will not get carbon monoxide, you will not get carbon alone over here. So you are only going to get carbon dioxide and water for complete combustion of alcohol. So do remember, for combustion of alcohol, you are only going to get carbon dioxide and water. Now, for the second reaction, we will look at the nucleophilic substitution of the reaction with alcohol. Now, when you have alcohol, this alcohol can actually react with halogenoalkanes. This alcohol, they can actually react with certain reactants regions to give you halogenoalkanes. Now, we have three types of halogenoalkanes in your syllabus over here. One is when the R group is substituted with the Cl. The second one is going to be the R group is going to be substituted with Br. And the third one is where you have the R group being substituted by I. So if you want the R group being substituted by Cl, you can actually have 4 reactions involving this. So the first reaction is going to be with HCl. So if I write down the first equation, if you have an alcohol, let's say we have this CH3OH, and then we are going to react with HCl. And what we are going to get is we are going to get CH3Cl and then left with H2O. And you can clearly see that we are going to get the RCl and you are going to get the water. If you want to get this halogenoalkane, what you need to do, because there is a presence of water over here, what we need to do in order to get that halogenoalkane, you need to actually use distillation reaction, and then only you are going to be able to get the CH3Cl. Now take note that this HCl is going to be prepared in situ. Okay, it's going to be prepared in situ. So what is in situ? In situ is going to be the reaction is going to be done in the same reaction vessel. Okay, in the same reaction vessel. So when you actually have, if you want to prepare the HCl, we are preparing the HCl by using sodium chloride and concentrated sulfuric acid. Okay, concentrated sulfuric acid, and we are going to get this salt over here and then HCl. Take note, we cannot actually use this same equation to create HBr and HI. You can actually have a look at the group 17, because we have learned that HBr and HI will be further oxidized by sulfuric acid, concentrated sulfuric acid, so they will not actually remain as HBr and HI. So in this case, we are only going to stick to RCl. Therefore, we are going to actually use the HCl over there. Now, for the second part of the reaction, if you want to actually react, and then you want to get chloroalkane again, what we can do, we can actually, if you use this example, CH3OH, and then we have SOCl2, we can actually use this reaction to form CH3, the RCl. You can actually form CH3Cl plus SO2 and then HCl. Now the difference with this over here is both of these products that we are going to get, they are gases, so therefore they will actually escape to the environment. So if you want to actually collect this particular halogenoalkane, it's much more easier compared to the first method, because the first method you need to do distillation to separate the water, but this one you are going to get CH3Cl directly. So this is going to be the advantage of using SOCl2. Now let's have a look at the third reaction. The third reaction is going to be by using PCl5. Okay, so I will write down the example: CH3OH plus PCl5. What you are going to get? You are going to get CH3Cl plus HCl and POCl3. Now POCl3 is aqueous, okay, and HCl is going to be gas. Now if you look at over here, it is slightly different than the second reaction where you are going to get gas and gas. HCl is going to be hydrogen chloride gas, is going to be joined together with sulfur dioxide gas. But for this reaction, you only have hydrogen chloride gas. And this is going to be a good test, okay, using PCl5. It's a good test to identify the presence of OH. So if you want to actually test for alcohol, we tend to actually use the test of PCl5 to test for alcohol. By identifying the gas HCl that is going to be given off, it will give you the observation is going to be white steamy fume. So the moment you see white steamy fume, you are going to be you can be very certain that this the region that you are testing, the substance that you are testing, is going to be alcohol. Now take note, the first reaction that we have is going to be heated under reflux. Okay, heated under reflux. If you do not understand what is heated under reflux, refer to my previous lesson. Heated under reflux is going to be you are heating something without evaporating the substance. So you are going to heat and then continue to reheat until you have the substance or the product that you desire over there to be formed. So heated under reflux. Here the second reaction is also heated under reflux, but for the third reaction, because it's a test, one of the reason why this is going to be selected as a good test is going to be it is done at room temperature. So you do not need to actually heat the reaction with PCl5. Now for the fourth reaction, you can actually do the test. Okay, you can actually do the same thing using PCl3, okay, to give you the RCl. So if I write the equation, let's say if I'm going to use this, okay, plus PCl3, you are going to get CH3Cl plus H3PO3. Now this one you are going to get the RCl, you are going to get the H3PO3, but the thing that you need to do, you need to still heat the substances. So it's going to be different than the first one if you are using the third one if you are using PCl5. So these are the things that these are the reactions where you can actually form the RCl. Okay, RCl, you can see this one. If you want to form this RCl, you use this RCl. Basically you are going to get this halogenoalkane containing chlorine. But let's say if you decided want to actually use this reaction to produce RBr, so what are the reaction that is going to be suitable? Are we going to actually use the similar reaction by HCl, SOCl2 and PCl5? The answer is no. If you want to actually use if you want to form a halogenoalkane containing bromine and containing iodine, you need to actually remember that we need to follow this reaction by using PBr3 and PI3. Now PBr3 and PI3, they are going to be prepared in situ, similar like my explanation earlier. In situ means in the same reaction vessel. How do we do that? We have to use the red phosphorus, the P plus Br2 to give you PBr3. The same thing applies for PI3, where you have to actually do it in situ as well. You are going to have P and I2 to give you PI3. So what is going to happen over here? We are going to put phosphorus and bromine gas, and together with the alcohol that we want to react. So once the PBr3 is being formed, you are going to actually react, the PBr3 is going to react with the alcohol directly. That's the meaning of in situ, in the same reaction vessel. So if I actually write this equation to produce RBr, if I am using CH3OH, and then I'm going to react with PBr3, what am I going to get? I'm going to get CH3Br plus you will get H3PO3. Okay, that's a reaction. If you are reacting using PI3, you are going to get this reaction, CH3I plus H3PO3. That is going to be what you are going to get. So do remember, you are going to actually use heated under reflux also for this reaction. So this one, all this will be heated under reflux. Heated under reflux. Now the last reaction for this part 1, is going to be by reacting alcohol with sodium. Now the reaction of alcohol with sodium is less vigorous than water. As you know, sodium can react with water vigorously to give you effervescence. The effervescence is actually caused by the release of the hydrogen gas. Similar to that, alcohol can react with sodium to give you salt and hydrogen gas, but the reaction is going to be slightly less vigorous than the reaction with water. Now take note that as the number of carbon of that alcohol increases, the reaction is going to be will become less vigorous some more. Now you can actually write the equation. If you have ROH plus Na, you are going to get a salt and then the water. If I actually write it down in this different form over here, if I put it in this form here, if you have CH3OH and then I'm reacting with sodium, what I'm going to get is I'm going to get CH3O minus and Na, and then half hydrogen gas. Now what is this? This is going to be a salt. This salt is given by the name. You just write the sodium, and then the salt, okay, is going to be ethoxide salt. Now this sodium ethoxide salt, okay, if you have excess alcohol, all the sodium will be completely reacted. All the hydrogen is going to be given off, okay, to the environment. So what you have, you are only going to have the alcohol and the salt. Now take note that alcohol can evaporate easily, it's volatile, but if let's say you just leave it just like that, alcohol will evaporate and you are going to get the salt over there, the ethoxide salt. This ethoxide salt, okay, under the presence, let's say you heat it a little bit, what it will form, okay, if if you just together with the reaction, they are going to be aqueous because sodium is going to be soluble in water. But now if you let it to evaporate, this salt can actually form crystals, so it will form a white crystalline solid. So this is going to be one of the point that you want to take note, one of the observation that will happen, crystalline solid, where the sodium ethoxide salt is going to form a white crystalline solid if you let it settle down under the room temperature or heat it a little bit. So one of the observation, the hydrogen that you get is going to be, if you test with lighted wooden spleen, you are going to get the pop sound. So this is going to be the summary of the first part of the lesson. Okay, so these are the summary. You can have a look. Okay, thank you everyone.